in last video we implemented our map and our map2 functions, which are inspired from the Kotlin standard library. And today's video we are going to implement our map indexed and our map indexed2 function. So first we can understand what is map indexed function. So I can call this, and now the benefit of this function is if I'm interested to know about the index of my item in a collection, I always go with this. Otherwise the operation is still same, just like we do in a map. And I can show you, like for example in this case my string s will be 1 first time, then 2, and plus we can check index, and the index value will be, we can print here. So once I will run this, so now you can see in this case I'm also getting the index. So at 0 we have 1, at 1 we have 2, and we can print this. Now what is our goal? So our goal is to implement the same functionality, but that will be our map, and by doing that we will learn something new. By the way, if you are new to this video series, these are the prerequisites. Please, if you have a feeling you are not comfortable with these three things, please try your best to read about this first, or I have also a video on this, and otherwise it's good to go. So what I need to do, basically, first I need to create a function that I'm sure with this name. Okay, this is here. Now what I really want, I want this is implemented on a list. So just like we already discussed in some last videos, I will say, okay, you will be, first is my generic function, or maybe first I can go only with this string. So I'm only implementing for the string, but internally this map index function is implemented generic for everyone. So in my case, I'm saying, okay, I will implement for you only for my this function. So now we achieved this part. Now I want to achieve this part. It's a lambda. We are aware of this is lambda, so I need to create a lambda. And in this case, what I am looking for, because it's specific to the string, so I'm saying, okay, I will send you a string, and then you need to return me also as a string, because this is creating a new string. So string and string, and also I'm interested in a index, so I can say index and string. No need to mention like this, int and string. And then after once this implement the transformation is complete, is returning as a new list of string. Later we will refactor this, so I'm currently only focusing on this part. Now inside of this, what I want for loop item in this. So this is a list because it's extension function on this. Then what I want a new list. So I need to create a destination which will be array list of string, and size will be this dot size, because list is extends from the collection and collection have this value inside. Then what I want, add the new value after transformation into this. So in this case I will send item, but what about the index? Also I need to send an index. So I think there are two ways I can achieve by doing this. I in 0 until this dot size, and then I can send this I like this, and transform in this case, then I, and then my item, and I need to collect this item from this dot I and this. So in this case functionality, we achieved what we want, but I'm going with this one because the standard implementation in a Kotlin standard library, they are using the same technique. So I'm going with this, but in this case we need a extra state which will be index, and my index is responsible to count. So now both are same, but I'm following this one. What is that thing? Use with index also. No, I'm not going to implement that. Now we will run and then we will see. So both are giving us the same. Now what's the issue here is currently, for example, I have a ints is equal to mutable list of 1 2 3. So if you see, ints dot map index is working, but if I try dot our map indexed, it's not showing our map index because we have hard-coded values, like it's only for strings. So now it's time to improve that. Maybe we can write this here still until we achieve this. So now we are going to make this as generic. So first I know this will be a generic t, makes sense. Then we, as a map function, it's not compulsory you always return the string. You can return any kind of a data structure. So in that case I will say t and then r, I will return r. Now this is the list, and I'm also going this to its parent, which is an iterable. So by doing this, it's not only for the list, anyone who is implementing iterable that can access this method. Then at this point, int is always int, no need to change. In case of a this string, what should be this string is, so basically this is an item. Item means it's coming from the list, and this is a returning type, and then this is also a list of returning types. So now we achieved this what we want, but now there is one issue, this dot size. Just like we discussed in a last video, if the iterable is extends from the map, the collection, then we have this value. If someone is trying to, like this, I have a collection iterable, for now I'm using like this string. So in this case we don't have this, this is an iterable, yes we are sure, but there is no size because it's not a collection. So in that case we need to give some default value. So what I can do, maybe I can make this a generic function because we need to use every time this inline fun, and what should be the name, collection size or default value, or default collection size or default. And how this will work, this should be implemented as an extension function, and if this is generic, I need to mention this as a generic. Then what we are expecting to return the integer, and this is the implementation, and here we can send default, no need to do hard code this. So in this case what I can do, I can remove this and I can call directly here this, and in our case it's the same. What I want, collection size and 10. Then what's next? In this case the transform is saying required is string because this is a hard code. So I am expecting r, now it's generic. So now this is a proper function. Now you can see it's saying yes, I can see. So now we are able to make a generic function, OurMapIndexed. If we run again, this should work. Yes, still same. So now we can move to the next part. Okay, I'm making this inline, and now the next part is inline fun. I want to make this function our map index 2, just like we did in map. You can see here, and the benefit, you guys remember, the benefit is one, we are able to refactor our this function, we will see, and then also it improve the time and space complexity in some cases where we have a 2n time complexity, and we are able to improve to n, and space complexity is n, and we improve to constant. So that's why I am going to implement the same, just like maybe I can do this copy and then we can refactor this. So our map to, it's a same like our map index 2 we have built in one. Now what we really want in this case, we are saying okay, we will send you a array list or the data structure, the collection data structure where you need to save, but what type of that data structure. So basically in this case it's a list of R, and we are still interested in the values, a collection with the values of R. So what I can do, I can create a new collection. So I'm adding the constraint. So what I'm saying, okay, there will be a C, third generic, and the constraint is it should be always mutable collection or extend from the mutable collection, and then this will be C. So here I'm not able to, when I try to give her some wrong data type, it will not accept at a compile time, and then I am also going to return the C, because C is now taking care of. Okay, I think this looks more nice. So this is done, we are able to achieve this. What's next? In this case, I need to copy paste this part, because now the destination is coming as a parameter, index I still need, everything is still same, and in this case we can improve by calling directly return our index map to, and I need to copy paste this here and transform. So in this case everything should works just like, yes, so it's working. Now what we can do, oh sorry, I can change, this one is working, I can move this to our index 2, or maybe I can create a new data, and it may be mutable list of integer 1 2 3 and 4. And now what I want, data dot our map index 2, and now I want a new collection, array list of string, maybe size is data dot size, and my transformation I can also put outside index because it's in Kotlin, and the value will be int, and I'm expecting to return, because it's a string, it means I have an index, I can say value, so I will say do index plus value and then change to string. Once this is done, I will get this array list as a return type, so do. Now you can see 1 2 3 4, and once I apply this, 1 plus 0 1, 2 plus 1 is 3, 5 plus 2 3 plus 2 is, so it's working as per our expectation, our map index 2. We can discuss what is the benefit of this method. So if you already watched my our map video, then you can skip the remaining part, because I'm going to repeat the same thing. So I can go with the different data. so I can show you properly what is the when you can use this and what is the benefit of this. So for example, I have again same or maybe names and C. So what we really want, so this is the scenario. For example, from somewhere we are getting this data, maybe API or anywhere, and now I want to merge this data with this. And not only merging, I also want to apply some transformation. So for example, I want to put a postfix kind of maybe new or something around that. So I will say map. We can use our map also, but I'm using now the built-in function, and then I'm saying post and operation. Then after that, it will give me the new list, and I will say okay, data add all, and then print this, or maybe print separately. It will show you more easier to understand. Okay, now you can see A, B, C, 1 post, 2 post, what we want, it's happening here, but there is a, there we can improve. So in this case, this is a n operation, then add all is a n operation. So basically it's a 2n operation, and then internally this map create a new array list, which is this, and then we are adding that here. So it's an extra memory, but I can improve. It's like the output will be same, but the improvement will be time and space complexity. So what I want, basically I want to apply a function on these values and then add this into data. So in that case, if you remember, we implemented in the same way, add in a data, and what is my operation I want to apply. This will be index and item, and I want item plus post, and then I can print out data. Now run. So again, the result is still same, but there is a achievement of time and space. So in this case, if we trace this, so you can see list our map indexed. So we are calling this iterable is this list. It means this is a list. Then item will be always A. First time is A, B, and C. So that is complete. Now this destination is our data. So we are not going to make any new data collection. It's a same data. So there is no new data array list. It means we saved a space. Then after that, I'm applying the transformation and adding at the same time, because in the case of a map, first we separately applied and then after we added. In this case, I'm not separately, I'm applying and saving at the same time. That's why it's an operation. So I hope we learned something new today. See you in the next video. Bye.